So this lesson is the first lesson into mechanics, year 2 mechanics. Good thing with the year 2 mechanics, good thing, bad thing with the mechanics is majority of the stuff that you'll be tested on the real A level will be based on the year 2 stuff because each chapter is a big topic. So yeah, so the first one is about moments. With moments, the exam focus is probably on these three chapters. Okay, so these are the exam favorites. So the first two, 4.1, 4.2, which we're going to look into in this lesson, is a bit of introduction to what moments is. If you've done physics, you would find yourself quite familiar to those concepts. However, in terms of calculation, there will be more in-depth calculation compared to physics. Right, so let's dive in. Right, so what's moments? First of all, the moment of a force is the turning effect of a force. Sorry about my writing. Turning effect of a force. The larger the magnitude of the force, the further away from the pivot, the greater the moment. Right? So the moment of a force, when you apply a force to something that is turning, that generates moment. Okay, so moment is not something you can see, but you can sort of feel or you can sense. When you apply a force turning something, that's the moment. For example, when you have a door, okay, now I'll try my best to do a drawing. This is a door frame. Okay, so you have a door in here. Okay, you have a door in here, and in here you have hinges, right? So hinge. So this door is currently open, right? Next, you also obviously have a door handle in here. Usually door handle on this side. Now, one would be thinking, why is the door handle on this side? Let me tell you, if, okay, say we open the door, let's say we've got two scenarios. We open the door here. 1, 2, 3, 4. Oh, that's this person 6 fingers. Well, don't be racist. This person 6 fingers, 6 fingers. It is. Right. And scenario B is another person, maybe open the door here. Right. How many? 1, 2, 3, 4, 5. This time 5 fingers, even though the thumb, even though the fingers are in the wrong position. Who cares? Right. Now, think about this. I want you to imagine if the red person, okay, try to open the door on this side through the hinge, what is going to happen? What's going to happen is he will find himself very difficult to open the door. Now, even though the orange guy and the red guy is using the same amount of force trying to open the door, the red guy will find himself having to use so much more force if he was to open the door as easy as the orange guy. Now, why is that the case? Because in the door, when you open the door, the pivot is here. The pivot is by the hinge, right? So that's the pivot. Now, sorry about my writing again. It's the pivot. Now, when a guy opens a door through the pivot, sorry, not through the pivot, there's a hinge on the pivot. When a guy opens the door from the door handle, which is quite far away from the pivot, then you generate more moment. Now, look at this sentence again. The larger the magnitude of force, so imagine you opening the force, okay, forcefully, and then the further away from pivot, so you're further away from pivot, the greater the moment. So you can easily open the door because generate more moment. Comparatively, if you compare to the red guy, when you try to open the door in here, the position of his hand is quite close to the pivot. So therefore, the distance of the hand to the pivot is nearly 0. When it's nearly 0, it generates nearly 0 moment because, you know, when a number times 0 is nearly 0 or 0 point something is close to 0. So therefore, it will generate less moment. And that's why the door handle is always furthest away from the pivot, right? So next, the moment. So what is moment equal to? Moment equal to the magnitude of force times the perpendicular distance away from the pivot. In short, we can use a formula to represent M equals FD. If you have a highlighter, I want you to highlight the word perpendicular. So the distance must be perpendicular from the pivot, right? A classic example, opening the door, imagine is that opening the door on the right, which is the pivot by the hinge, is very hard to open because the perpendicular distance is nearly 0. You can write in here because the distance is nearly, or we a bit more mathematically, we use a double equal sign, nearly 0, roughly equals 0 meters. Therefore, therefore, the moment equal force times 0, which is 0. The unit for moment is Newton meters because force is newtons times the unit for distance meters, newtons meters. All right, it's a weird unit, but it is what it is. Right, next, let's move on. Example, find the moment of the force on P. On P means this is the pivot, right? There's a reason why they use P. P stands for pivot in here. So that's the force. The force is 8 Newton. So we want to find the moment of P. So moment equals force times distance. The force is 8 Newton. The distance, perpendicular distance, is 3. So 8 times 3, which is 24 Newton meters. Now, one also need to know is when you apply a force to turn something, you could turn both ways. You could either turn clockwise or anti-clockwise. Now, I want you to think about the distance as a door. So I want you to write this down, okay? So think of distance as the door. So this will be the door. Okay, so this will be the door, right? This will be the door. Now the arrow, look at the size, look at the direction of the arrow. You're pushing upwards. So how would the door rotate? I want you to think about this. This is a hinge. That's a hinge. That's a pivot. There's the door. When you push it that way, when the arrow means, imagine you are rushing through a door. When you're pushing the door that way, how would the door rotate? It will rotate that way, wouldn't it? So this way is clockwise. So therefore, we say 24 Newton meters clockwise. In moments, you must specify the direction. As I said, because moments could be both ways, and later on the direction will be very important in terms of calculation. If you got the wrong side, too bad, you got the wrong answer, right? Next one. So example, find the moments of each force on P. Now P is a pivot. There are 2 forces, 5 Newton, 6 Newton. So let's do it one by one. Let's do the easy one, which is 5 Newton. Okay, so let's do it 5 Newton. So moment equals force times distance. The force is 5 Newton. The distance is 2 meters. There is a right angle. So we're happy with the 2 meters. We use the 2, so that's 10 Newton meters. Now, think about what's the direction then, okay? Use the distance as the door. That is your door. That's the door. When you push it in the same direction like 5 Newton, how would it rotate? It will be rotating clockwise. Because if you push it upwards, the door will rotate that way. So we can use dW for clockwise. Next, for the 6 Newton, however, you can see this time it's not 90 degrees. So this distance is not a perpendicular distance. That's a symbol for perpendicular. A right angle plus an R is not perpendicular. So we have to find it. We have to find the distance first. So how do we do that? Well, we draw a perpendicular line from the pivot to 6 Newton. Let me use a different color. So from the pivot, go down to the force, that will be the distance. So what essentially what we have to do is I'm going to draw the triangle out again, the distance, 3 meters, and that's 60 degrees. So using trigonometry, that's hypotenuse, that's the opposite, use sine. Sine 60 degrees equal opposite over hypotenuse, multiply 3 across, distance equal 3 sine 60 degrees. You can plug it in a calculator. Sine 60 is √3/2. That's 3 √3/2. So let's go back to the original calculation to find the moments. Moments equals force times distance. The force is 6 Newton. The distance, the perpendicular distance is 3 √3/2. I'm going to just put it in the calculator and give a decimal, 15.6 Newton meters. in mechanics, we tend to use decimal. Reason being is decimal give you a better idea of the magnitude of the force. Imagine if I tell you, okay, so someone ate 15/2 slices of pizza compared to 7.5 slices of pizza, which would give you a better idea how crazy that person has eaten. 7.5, all right? That Michelin obviously has eaten 7.5 slices. So you would, the decimal fraction, even though they mean the same thing, they have different purpose of presentation. So we use decimal for mechanics usually. What about the distance? Sorry, not direction. That's the door. That's direction. That's the door. D also stands for door. If you're pushing, the 6 newtons pushing upwards, the door is going to rotate that way. Right? So that will be anti-clockwise. And that's the answer. So 2 key points take away from here. One is think about the perpendicular distance as a door to work out a direction. When drawing a perpendicular distance, you start from the pivot. If you're a big fan, I'm a big fan of Friends. That's why the first thing I think about when it comes to pivot is this one. I don't know if you know the reference. Anyway, so the distance is the door. Okay, so the direction of the force tells you which way the door is going to rotate. Whichever way the door is rotating, that will be the direction for the moment. Right, move on. 4.2. I'm going to do one lesson altogether because that will be too short. 4.2. So resultant moment. So what's resultant moment? Now, if you want to pause the video and ever go exercise 4A, feel free. Okay, but I'm going to go through, continue to 4.2. So I would suggest you do some question in 4A first, and then come back to this video on 4.2. Right, 4.2. So resultant moment. Now, before I explain what resultant moment is, I want you to think about this scenario. Okay, so here's a door. Okay, here's a door. Here's the hinge. Just in case you're not aware of what I'm doing, that's a hinge. Okay, and that's the door. Every year, there will be some little silly, crazy kids, year 7, year 8, coming to school. And one thing they like to do is pushing a door against each other to try and lock their friends out of the room or in the room. So here's some year 7s. Okay, so there are some year 7s. There's some poor year 7s. Okay, and then there are some year 8s. Okay, so year 7, year 8. Now, can you tell me, okay, when they're both pushing each other, how would you decide which way will win ultimately? Obviously, the answer would be whoever could generate the bigger force, right? Whoever could generate the bigger moment will win. So we have sort of like 2 directions. This side, the year 7s, are pushing that way so that could generate clockwise moments. And these year 8s on the right-hand side generate anti-clockwise moments. So the winner depends on which direction can generate more moments. If the year 8 pushing more, giving more moments, then obviously the year 7 will be locked in. But if the year 7s somehow are Popeyes and they try to they outforce the year 8s, then obviously they win and they lock the year 8 back in the classroom. So what's resultant moment? Resultant moment is basically the verdict. Okay, so which side will win? The resultant moment, we call it sum of moments, is the sum of clockwise moments subtract the sum of anti-clockwise moments. All right? So we'll have a look at an example. Find the sum of moments about point P. So just find the sum of moments at point P. You've got 3 forces on there: the 5 Newton, the 4 Newton, and the 3 Newton. To find out which force or which direction will win, clockwise, anti-clockwise, would you have to work up the moments of each force? So step 1, okay? So you have to work up the moment of each force to begin with. So you've got 5 Newton, let's work out 5 Newton. Okay, so moments equals force times distance. The force is 5 Newton. The distance, we love to see a right angle because when you see a right angle, that means we can use the distance. It's 2 meters, 1 meter, that's 3 meters. That's 15 Newton meters. Now, where's direction again? Sorry, where's the distance? The distance is here. So that's your door. When you push it upwards, you can see the direction of the 5 Newton. If you push it that way, or you try to pull it, the door will rotate that way. So that's clockwise, right? Let me just get rid of the color clockwise. So you must put down clockwise. Next one, 4 Newton. Moment equals, the force is 4 Newton. The distance is 1 meters. That's 4 Newton meters. Which way is it? Well, that's the door. You're pushing it downwards, the door will rotate that way. That way is anti-clockwise as well. Okay, so not as well, but it's in this one anti-clockwise. Last but not least, what are 3 Newtons? Okay, so the 3 Newtons, the same. Moment equal 3 times the distance away from P is 1. So 3 Newton meters. Direction, that's your door. You're pushing upwards. The hinge is at P. It rotates that way. That way is anti-clockwise way. So what is the sum of moments? The sum of moments, or we'll call it resultant moment, sum of moments, is the sum of clockwise, 15, minus sum of anti-clockwise, 4 plus 3, which is 8 Newton meters. That will be clockwise, because the clockwise moments is bigger than anti-clockwise. Basically, add and subtract. All right. So yeah. Okay. Let's have a look one more. Next, for this question, okay, P is a pivot. Again, there are 3 forces, 5 Newtons, 6 Newtons, 4 Newtons. So to work out the resultant moment, you do have to work out one by one. All right. So let's do the sort of the easiest one, which is 6 Newton, because the 6 Newton is a vertical force perpendicular to P. So, but there's really no, it should be, after the finish lesson, you should be confident to do that more, okay? But 6 Newton will be the easiest one. So let's do 6 Newton. But it doesn't matter which one is not. So moments equals the force, 6 Newton, times the distance, just 3 meters. So that's 18 Newton meters. That's the door. You're pushing it down, so the door will rotate that way. That way is anti-clockwise. I always have trouble figuring out the direction. So that's the anti-clockwise. Next one, so I'll put the take next to it. 5 Newton. So now for the 5 Newton, where's the perpendicular distance? Now clearly that's not a perpendicular distance because there's 80 degrees in there. So to work out the perpendicular distance, remember you have to draw a perpendicular line from the pivot to the force. So use a ruler from P, position it so it makes a right angle, possibly there. That's your distance. So to work out distance, I'm going to draw it out again. It's up to you whether you want to draw the triangle out. So that's distance, that's a right angle. There's 4 meters in here, and there's 80 degrees. So we have opposite and hypothesis and hypotenuse. Too much statistics in my head. Hypotenuse, that's sine. So sine 80 degrees equals d over 4. So d equals 4 sine 80 degrees. You can, I'm going to leave it as it is right now. So the moment equals 5 force times distance, 5 times 4 sine 80 degrees, which is 19.7 I've got Newton meters. And that's the distance, which also means the door, when you push it up, the door rotates clockwise. Last but not least, the 4 Newton. So I've done the 5 Newton, let's do the 4 Newton. So where's the distance again? Let me use different color for 4 Newton. This is 40 degrees, that's not perpendicular. So I need, from the pivot, your pencil should be on the pivot, draw a perpendicular line onto 4 Newton, is here. Right? So that's your distance. So to work out distance, I am going to draw triangle out. If you're familiar with your trigonometry, you don't have to do that. So D, that's 40 degrees, that's 3 meters. Opposite hypotenuse against sine. So sine 40 degrees equals D over 3. And now if you do correctly, your distance will always be on top of the fraction. So d equals 3 sine 40. So for moments, it will be force times 3 sine 40, force times distance, which is 7.7 I got, or 12 Newton meters, 7.712 Newton meters. Direction will be anti-clockwise. So therefore, verdict. So what's the verdict then? The verdict is the resultant moment equal the clockwise moments 19.7 subtract the sum of anti-clockwise moments 7.712 plus 18. So if you put that in a calculator, you get negative 6.02 Newton meters. Now, what does negative mean? Negative means anti-clockwise because it started with clockwise. That means anti-clockwise bigger. So it means ultimately 6.02 Newton meters anti-clockwise. You cannot leave it negative. You must put a direction in there. You can put negative 6.02 clockwise, but a better answer will be 6.02 anti-clockwise, if that makes sense. Right. Is that it? Yep, that's it. That's it for that's it for 4.1, 4.2.